So I think we could keep going a little bit through the paper doc, but I also wanted to talk, what I'm hoping will kind of get to overall is a sort of census of where things are at and help us figure out what priorities we should be doing and so forth. One of the things I started experimenting with just in the last few minutes, let me share my screen. I thought I disabled those notifications. All right, I'm just going to quit this out. I started messing around with oh my God, I keep getting dingy sounds and it's driving me crazy. Even after quitting all the apps and disabling everything, there we go. Okay. How do I share my screen? Why is it not on the list? Okay. I created this GitHub project thing, which I always try to use and I always fail to find a lot of value in. But I was thinking that maybe to help us track the overall, an overall view of what's going on, it may actually not be the worst UI. Obviously, I just put a dummy thing in here, but we've talked a lot about having sort of a place where people can go and get an overview of what's going on, and I think it'll be helpful for us too, to be able to say like, here are the projects that are active, here's some that are stalled out, or, you know, and with links, it's kind of a tracking issue, I guess. So maybe it's better to just make tracking issues at the end of the day. But I wanted to go and toss it out there for thought. I think we should be able to, I would like it if we kind of had a good list like this. So here's the things, and here's the ones we're focusing on, and here's the ones we're not right now. And some notes on why, right? I think we sort of don't at the moment have a central place where we can observe that information. I know I'm always discovering new things along the way I've forgotten about.
So that interface that you showed, the project view, the main benefit I see of it is that it gives you a sort of two-dimensional view of the status of many things at once in terms of the issues themselves, without the ability to encode much metadata about, like, you know, discussion or, you know, supporting text describing the status, because that would perhaps defeat the purpose. Is that accurate?
I think that's right. Yeah, we could debate what these columns are too. Like, I think you could imagine them being people in the team, for example, organized by liaison, and maybe another column of like doesn't have a liaison, and therefore, you know, that would sort of help to visualize what we've sometimes talked about giving people a way to visualize the.
In the limit, you jump to a spreadsheet, right, with the pivot tables and stuff.
I started with a spreadsheet and I jumped over to this. I wasn't enjoying this. I guess let's not go too far down this, but this is probably better to discuss async, but it's something to think about. So coming back to the addition planning stuff, we got down through somewhere around type description. I guess we were talking a bit about implied bounds. I forget exactly how far we got. We didn't get that far in preparing for this meeting.
I believe we got through the entirety of what was under ergonomics initiative and other unfinished business, except for things that got added after that meeting to be discussed.
Yeah, we definitely got through idiom lints and so forth.
Right. I think we may not have discussed the section labeled other candidates. Where there's like minor bullet points that didn't really get thorough discussion there.
Yeah.
And then we discussed one or two of the items under new or other items thus far.
So okay.
Do we want to discuss RFC 2115 and 2145, or do we want to move on to the other item?
Let's discuss these briefly, but not spend too much time. I'm going to put let's say 15 minutes, and then we'll start looking at the newer other items. So I did look a little bit, the in-band bindings and lifetime elision. I refreshed my memory here a little bit. So the in-band bindings, if everyone doesn't remember, is you didn't have to declare lifetimes explicitly. We kind of inferred their scope from where they were used. And there were various details to do with that. It kind of got implemented, but it's not, I don't know, not been widely used, I think, and there were some concerns about the design as the way it stood. Then lifetime elision, this was Scott's RFC, right?
Yep.
Basically saying that in associated types, you could use tick underscore to refer to one of the implied lifetimes from this. Like if the inputs of the input types in the impl header are like function parameter types, essentially.
Yeah, basically making all of the self type and the arguments there to be input in the sense of like function arguments, and then associated types are outputs like function return type, position, and then just copy over the same rules.
And the main concern here was, if you scroll down, there's a good comment summarizing it, that there's a sort of surprising-ish interaction between elision at the function level, where this return type refers to one of the parameters, and elision, but you might expect, if you wrote like basically if you write self::: item, you get this type, and this elision refers to that lifetime, and everything works. But if you inline the definition, then this &t now refers to here and not to here. And so you get an error about having the wrong lifetimes here. And I can attest that we've been working some on, I know like Estevank has been working on trying to get the error messages in the compiler better in scenarios like this, and it's really hard. Kind of hard to explain to people what's happening in a concise way. And I guess it would be, I don't know if this, I guess it wouldn't make that harder or easier just to say this isn't a point of concern. I don't know, but it's not like this has been highly controversial. It's not like it's a huge implementation challenge. Mostly do this design question, right?
Is it theoretically possible that this could be done in a edition compatible way, or?
Totally compatible.
Yeah, right now anything where this would happen is an error because you didn't specify a lifetime and you have to.
Okay, so then while this is a valuable feature, is there any specific reason we should tie this to the edition? As opposed to just doing it and when it's done, everybody has it?
I suppose none of these lifetime things are actually edition tied. In-band wouldn't be either, right?
That's right. I think
that's what I'm asking. I think for the purposes
it's not tied to the edition, but it's thematically like, is this the kind of work we want to be doing at this moment in our lives? I definitely feel inclined to do smaller things like this and leave out the more aggressive in-band lifetime bindings, which doesn't, even though
that was
badly.
that's sort of why I ended up writing that RFC, actually, because the conversation in-band was got to the point where my biggest feeling was we should try and elide more, and then if after we've successfully elided more we go, man, this is still a pain, then we do in-band or something.
Yeah, I don't think it's gonna really, I guess I don't think this scenario is that common that it's gonna really dramatically change my desire for a lighter weight solution, but I also kind of feel like the most pressing problems, I don't know. I'm trying to get, in-band doesn't feel like it's solving it's neither the most pressing ergonomic problem nor a particular enabler to my mind, I guess is what it comes down to. So I'm inclined to hold off a little bit. But.
Yeah. The only place where output lifetime elision is particularly common is anytime you write into iterator impulse. And I don't know how many people actually do that.
All right. Why don't we, so yeah, I can put my note like, I guess there is a question mark here of like, is my hypothesis that I feel like, yeah, this ergonomic, I guess I'd like to understand better what we think around borrowing and so on the most pressing ergonomic problems are to address. And it would be nice if we had a strategy like we want to make, at some point I did have a plan, like I want to make it so that writing a iterator, look at that, look at what's required in that and make that as easy and painless and as possible, because I feel like that's a common use case of about that level of complexity. I hold a reference to a collection and I'm walking through it or something.
Yeah, I'd love to find something to make the I have one reference in a struct thing not quite so pain.
And that notably is not really addressed that much by in-man lifetime bindings, maybe a little bit.
It could, I don't remember if that proposal took it out of the struct header there.
So like, you mean the elision case? So in particular.
Well, elision doesn't, but
So
I don't remember if you had to put tick A in the header still for a struct definition that contained a reference.
You did, because otherwise the idea was that in function signatures and impulse, those are cases where you don't write those lifetimes because they're not types.
Oh, right. And since those aren't introducing it, the definition of the thing introduced the lifetime.
Yeah, and like they're more connecting pieces of the definition together. But in the case of a struct, you're gonna write somewhere else. You're gonna have to write like, you're gonna have to acknowledge this lifetime thing explicitly, and so it's really weird. What order does it go in? You can't sort of just infer it from the ether.
Right.
All right. So I said we should try to move on, so I guess I should try to move on. We didn't reach a conclusion, except we're like not exactly sure what the prioritization here is, but small steps seem to be. It's not really tied to the addition necessarily. One thing I might bring up, it's more of an implementation thing, but we had some existing RFCs, most notably, I think it's 2229, that talks about capturing of, actually this is addition related. I want to bring it up.
Oh, really?
Capturing enclosures.
Yes, please. Why is this addition related?
Why is this RFC addition related?
Why does it need to be tied to an addition? What's the backward compatibility concern?
That's what I'm about to say.
Unresolved question says drop order.
Exactly. So if you have today, let's say you write this code, what happens is that the closure captures all of foo. And so when the closure is dropped, then foo will be dropped. But you could imagine a version where the closure captured, I think you probably would want it to be that the closure captured foo.bar only, and thus the rest of foo is dropped sort of when it ordinarily would have been. If that makes sense.
I see. So in an addition, we could change that drop order, which is unlikely to be readily observed, I mean, you could tell, but code is unlikely to care if it's doing something like this. But in a non-edition, technically there might be code out there, especially unsafe code, which might be paying close attention to this.
Yes, I mean, I would definitely not be okay with changing the visible semantics outside of an edition, let's say. Inside, I think I'm definitely okay with it, but I do have not entirely sure what we would like. We probably how much
Want like Rust fix to warn about it or something? Yeah, like people upgrade. Yeah.
Like I might want that when you upgrade, we change your code to something like this, and actually, or some other weird construct that actually preserves the semantics by like kind of separating out the path so that you're accessing first foo and then foo.bar. I don't know. That's probably not what we would actually do. It'd probably be like let foo equals foo or something.
Right.
And then that would preserve the actual semantics, but any new code you wrote would work the new way, and maybe you can go back after and clean up these on your own, to make it, since you probably don't care most of the time. We could be a little more selective, like we could look for cases where the type actually, where we see a drop that might have side effects.
Oh, I think we'd have to. Yeah, or at least something that has a destructor, right? Because if we just injected it all over the place, people would go nuts, right?
Agreed. We couldn't do it for like every capture for sure. So I don't know exactly how selective we can get, but I think we would want to get somewhat selective. So that
it would be hard to find a way to silence the warning to say that this case where it's technically going to change behavior, I don't care because it's only dropping a string and whatever.
Yeah, I mean, I think we would special case, like we would know, for example, that box and string and vec. I feel like we would have a list of things that we know and that are just freeing memory and we don't consider them to have side effects. And I would even whitelist those or, permit those. In other words,
vec of mutex or something can exist, right?
Well, that would, yeah. So if we see a mutex guard, or like we'll recursively walk down, basically.
Yeah,
Okay, yeah.
So phantom data there or something would be the way it would.
The hard problem is going to be like vec of t, where you don't know what t is, because then you have to be conservative. But
do we feel like we need to automatically translate this in RustFix? Or is there any possibility we could just say, this is the new semantic in the edition, 99.9% of code is not going to care, and it would actually be intrusive to have RustFix do this when you probably just want to leave it and make sure your code still works?
I don't know. I feel a little uncomfortable telling people they can upgrade and then silently introducing a really weird bug because now some mutex is being dropped at a different time. And
do we have flags to RustFix to let people like opt in to say, look, for this particular transformation, don't apply this one? So that someone could decide on their local, that they're willing to take the risk of not having it applied on their code base.
What? I don't know. I don't know if we do, but we could imagine it. One thing I want to add is, I think we do in the sense that you can specify like link group that RustFix will be applying. And one thing I want to add is there are some people really interested in pursuing this implementation right now. There's a group of undergrads who came. And so I did have this on the deprioritize, but I'm sort of thinking about saying, okay, I will work with you guys because I would really like to see it implemented. I think it'd be a big ergonomic win. And maybe we'll get, like, we probably don't want to go much further into these details now, but these are the, we should probably prioritize like figuring out exactly what the options are and what we can figure out.
I'm curious, is there value in considering a more general change if we're thinking of doing this anyway? Something along the lines of, please stop caring about drop order already? Would there be value if we're going to make a change like this anyway in just gratuitously saying you're no longer allowed to care what order things get dropped in? If you care, call drop?
That's obviously not tenable. Like that would be a massive change to the language, but I think there might be more other variants that we could consider, like you could have a opt-in trait that indicates that the compiler can reorder your drops, for example.
That makes sense.
And then we could implement that for all our standard library types. This came up around async because we were having the problem that, if you remember, we made temporaries lifetimes in async match temporary lifetimes everywhere, and then that started introducing some cases where now
I remember that. Yeah.
Yeah.
There was a question of like, we had stabilized this and then we needed to slightly change it. Is anybody going to notice? I remember that discussion about async.
We hadn't stabilized it yet, but yeah, we were coming up on stabilization though.
Right. People were wondering if it was going to be breakage though.
Right.
One other question on this one. If we're talking about improving capturing enclosures, would a similar approach allow us to handle capturing in methods, like not capturing all of self just because you call a helper method that takes self?
No.
I think that has different Semver things than closures do, right?
It does, but in particular, I was considering the possibility of what if it's a private method as opposed to a public method.
I would dearly love to solve that problem. I don't.
Likewise.
The technique, it's a different problem. Like so here what we plan to do is basically change how closures desugar themselves. So it doesn't really change the borrow checker in some sense in any way, whereas the method problem does, because it requires us to, borrow checker doesn't look outside of a single function right now, and we would have to think about how does that appear in the function signature such that the borrow checker understands what's happening.
Technically, couldn't it be a desugar as well? You could say that you have written this takes ampersand mute self, but really you're taking these two things and you're just internally changing the calling convention of the private method to pass a couple of private mutable borrows. And then a caller just has to know that and say, oh, I'm really passing ampersand mute self dot B and ampersand mute self dot D. And then the borrow checker will just do the right thing with that desugar.
I considered that at some point. I think it could be potentially done. It's tricky because of recursive functions, and I guess I think it wouldn't be my preferred solution. I would rather that we try to solve it in a way that, or we at least explore what it would look like to solve it in a first-class way where the user could explicitly declare it without overhauling their signatures, but it's plausible.
Okay. It would be very nice to solve. If you think it's too different from capturing enclosures that we won't be able to do it in an addition, that's another question. But if there's any chance we could do that by this addition, because then it'd be a coherent story of, in general, we made the borrow checker better.
Yeah, which basically raises a point. I think it's sufficiently different that it should be thought of as follow-up work, but I think it's an interesting point. Another bit of work which I don't really want to go much into, but Polonius, sort of NLL 2.0, so to speak, has been making some, like, definitely made a lot of progress. I haven't really been following. I mean, we've been kind of slow moving forward, and I haven't been as involved. But it does fix certain problems, like most notably returning mutable references. So there's definitely like a.
Does this, I saw a reference and a slide where you talked about this. What are the chances that this would also allow you to have references elsewhere in your same structure?
You
had a talk slide showing that.
Yeah, it doesn't like directly enable that, but
okay.
We call it a foundational shift that enables that potentially down the line.
Do you know where on the spectrum from basically done but needs more performance work to has, bugs that need fixing that affect it semantically this is?
It doesn't have any. We're currently in the phase of trying to like completely re-implement the borrow checker with this approach. It's close to there, but it's not there. So the first step was get all the stuff working, and the next step was going to be optimize. I think
Okay.
it's a significant amount of work that remains, but there aren't like a lot of. I don't think there's really that many complex sort of theoretical questions. It's more of an engineering problem. So. All right, let's skip down a little bit. Type privacy, private and public lens. I actually want to skip over this, although unless people want to talk about it much. I didn't look at the status, but I wanted to talk a little bit about like these, maybe some of these bigger questions. There's a variety of things. Some are big and some are not big, but and we're at 30 minutes, so.
Well, we discussed unsafe opt-in, unsafe fun last time, so we can skip over that one, I think.
Yeah.
Perhaps we should talk a little about temporary lifetimes, which I think got added since the previous time.
Yeah, I probably put that in there. So there's this traditional quirk in our temporary lifetime rules that basically the gist of it is that in general, when you make a temporary, it gets freed within the statement. So sort of by the next semicolon, unless with the special case that somebody is, if that temporary is immediately being assigned to a variable, then it gets extended to the end of the block. And then there's one other interesting quirk, which is that the tail expression of a block is sort of considered to be outside the block for the purposes of where the temporary goes, right? So the next in other words, if this were to get freed by the next semicolon, that would be here after the variables in the block are freed. So this vec gets freed after the block. And that means that, for example, if it has a reference to y as it does here, that would be an error. This is kind of perennially comes up as confusing, causing weird error, surprising error messages from time to time.
Is this
probably also is helpful sometimes? But.
I was about to ask, what is the case where this is the behavior you want? I mean, was this entirely unintentional, or did we do this for a reason to enable some useful case?
This was intentional.
Because I thought at the time that you would want like this, let's say E here, and this to kind of be equivalent in terms of how they behaved with regard to temporary lifetimes. But I think we don't actually, I'm not sure that equivalence was correct. I mean, there are some differences, like we take advantage of. For example, braces tend to enable moves where they wouldn't otherwise have been. I don't know if there's a good example of here's an error you don't get because of this rule. I mean, I could make some artificial ones. I don't know how often they arise in real life. I guess you could look at this one and already see a little bit of something. Is that true? I don't know. I'm thinking this vector. I think if you wrote something like this, I think that would compile today, but it might not compile if we change the rules depending.
Well, presumably this would compile since 22 is copy. Oh, wait, you're talking about creating a reference at the end of the block that you expect to outlive the block, or?
I guess, yeah. So I actually think this could continue to compile depending what rules we did, because the idea is if we can see sort of by the structure of the program that this reference is going to end up in the variable x, we will extend it to the end of the block that encloses x, and that's exactly why it works today, and it's probably what would happen. There is though one other thing that's relevant, which is RFC number 66, one of the oldest completely unimplemented RFCs that I know of, and still kind of a good idea, though massively underspecified in the RFC itself. Proposed a change where it said, roughly speaking, it said if you are calling a function whose return type is, let's say, ampersand tick a foo, and tick a, well, let me not give it all specky and instead try to give the intention. The intention was that something like this would compile. I don't know what's the actual example from the RFC anymore, but let me think. I don't know, something like that. And the reason for that this doesn't compile today is because you make a temporary here. The temporary is parameter of this function, so it's going to get freed at the semicolon, which means that it can't live as long as the variable x. You get a lifetime error. But what this RFC said was, if you're calling a function like trim that sort of returns a reference, and that reference is getting assigned to x, and the reference comes from a parameter, then we look for the parameter it comes from, and we extend that temporary as well. So this would then live till the end of the block.
There's another really common case where this comes up, which is builder patterns.
Yes, builder pattern. Right, we have like builder new, and the methods all take amute self dot amute self or whatever.
And the problem here being that builder new creates something that isn't named, so it dies at the semicolon, and then ampersand mute returned by thing two doesn't last long enough.
Yep. So I could definitely see.
It'd be nice to fix.
At least doing RFC 66 would be great. These maybe investigating this other change and seeing what its impact would be, I think might go. RFC number 66, as far as I know, is backwards compatible. Tweaking temporary lifetimes wouldn't be. For the same reasons, you know, it affects when destructors run.
There's definitely a theme here, though, of like RFC 66, the closure thing. Several of these could very easily be told as one coherent story of, we made the borrow checker accept more correct programs.
Yes, and I think it's like targeting scenarios, right? We did a big overhaul with NLL. Now we're looking at like, okay, here's specific pain points we want to address.
Right. Yeah, I think this would be welcomed if we managed to tell one big coherent story with it, even if some of them are not necessarily tied to an addition. If we use the addition to say, we did, 8 things related to making the borrow checker accept more correct programs. Bonus if those things include Polonius.
Phrasing, though, accept more correct programs implies that we aren't including any breaking changes, which some of these things were. So I just want to be clear up front about whether we are actually, like, if the message we're looking to send is, we're just going to start accepting more correct programs, then just make sure we limit the scope accordingly then of what we do.
Sure, it may be that in doing so, it tweaks things like drop order, which would then potentially affect some unusual cases. We'd have to document and explain that and why we thought it was important. But I think there's still value in telling a coherent story here.
My feeling is we'll come back, I guess, and look at resources, but I'm going to guess we can probably at most do one sort of breaking-ish change, if even in this direction. So like the closure stuff might be the only thing we can realistically try to do, because there's people who want to do it and it's relatively well specified, and temporary lifetimes might not just be in their cards. But what should we look at next? I'm curious if people have any pets they want to talk about, or we can go down the list. I would sort of like to talk about async a little bit, but it's a big topic.
As a very minor one, I'm wondering how hard it would be and how much support there would be for changing the behavior of const inside of a function.
This one.
Effectively, const inside of a function is very much a footgun because it is the really unusual case that something can be used before it's declared when it looks like it's not a top-level item. Yes, exactly. Also,
types and things aren't in scope, and yeah.
So I am mixed minds here. I mean, the reasoning is like, why use a constant not a let?
That's a good question.
My reading of this is that like you can have inner FN items and they can appear after their usage point. And I thought const is like, I mean, you said not a top level item, but it is a top level item in the sense of it's like a FN. It just happens to appear in the scope of a outer FN, right?
no, that's what I mean. It's not appearing at the top level, and the behavior of forward references is unexpected inside a function. And I was actually going to
But
observe.
I'm trying to say, what I'm trying to say is that likewise, you can have an inner FN, and that could be declared or defined at the end of the function, and you can have references to it above its definition point. So why is that? And I would want that to keep working. So why would we change const here? It's
not different. And the thing I was about to say was that's confusing too. Could we fix that?
That's not a fix, in my opinion. That's a break. That's a serious break.
That was what I was trying to find out, is if somebody thought that behavior was important.
Oh, I definitely think it's important.
Interesting. I would find that incredibly confusing to read in code, but that's a different problem.
For what it's worth, I put, at least in C#, I put inner functions after their call site all the time.
Interesting. I use
and that
inner
seems
functions
to
all
even
the time.
be what I see in MSDN documentation for that. Now, that doesn't say anything about Rust necessarily, but.
No, that's an interesting observation. And if that is commonly used in other languages, then that is something people may expect to work. I would find that fairly confusing, but it sounds like that's not a good enough reason to change
Let's
this.
see.
I also put inner functions after because usually they're like helper details, and I'd rather have them towards the end versus up front. It's kind of like bottom up. But I also tend to avoid inner functions nowadays. So, but I don't know. I don't have a lot of appetite, but I would be more. I guess I'd like to. I would probably want to address the question of inner things more generally if we were going to go down this route.
Well, there's a second possibility that I could suggest here, which is perhaps the correct answer is what I think, was it Scott? You said, why not just use a let here? Maybe that's an opportunity for a lint of some kind, like why did you make this a const if you could have made it a let?
I don't think that was me, but I agree with that statement.
There might be value in reminding people, hey, let is not let mutes. Perhaps you want a let here if you're going to try to redefine it. I mean, at the minimum, if you do something like const x and then later const x, if you get a redefinition error, perhaps it could say, maybe you wanted a let considering you're inside a function.
If your intention is to have a const, but you want this kind of scoping, we could introduce a let const syntax to get the scoping you want. There might not be appetite for such a thing, but.
I mean, I think that would be extra confusing given that let is already constant.
Right.
So are there any, the one case that I can think of where someone did want a const is that they want to say matched on that actual const. Is there any other situation that anyone can come up with where
array lengths?
A let would not work?
So let's work with array lengths.
One of these days, I'd like that to work with non-const.
I want to table this, getting too far into the weeds here.
Yeah, it sounds like there is not consensus on this one, so I'm happy to drop it.
Yeah.
we have a note about weird nesting down below. Do we want to
Yeah, the only
segue this conversation into that one?
we could. I was going to mention that one reason to limit nested items, especially impulse, as is noted here, is to make IDE's jobs easier. But I feel like I don't know. The most we would do is probably like this is an easy thing to implement, and the most we would do is lint against it, right? We probably wouldn't go straight to a hard error or something. But I guess
Where
it's
the
not,
lint says you're making IDs work harder than they should have to work.
I mean, yeah, the hope would be that IDEs in the future can we can migrate this enough that IDEs just don't work if you have impulse in the wrong places, and they just don't, like autocomplete and stuff doesn't work, and you probably want to migrate to the newer edition and stop doing that. But that may or may not really be a viable plan, and I don't know. It seems a little premature to me. But
It sounds like this may break more than it will help.
I guess the only thing we really have to worry about is impulse. It's specifically impulse for types that are externally visible, right? So it's something like as opposed to this. But
so something that I actually do quite often is to have a type defined in one module and then impulse for that type defined in another module.
yeah, that's a little bit different, but I'm not convinced it's that much different. I think I also do that a lot, and it's useful. And basically, I think it's a little premature. Like we should try hard to implement the language in IDEs efficiently.
Well, the flip side of this is if we were going to try to handle this, it seems like it would be a special case of a more general problem. Should impulse have scope? Like, should there be such a thing as a pub impl versus a non-pub impl versus a pub crate impl? Inside this crate, you're allowed to use this as debug or display, or I'm not suggesting you should be able to, but if we were going to try to solve this, perhaps it's by more generally making impl and scopes interact more reasonably.
Did Rust used to have that, Nico?
Well, there was a period where Rust had importable impulse.
Oh, right. Okay.
I think we could do things like private impulse as long as you still respect the coherence rules without great undue difficulty. So you'd be able to have an impl that you can use but others can't, but you want to avoid the situation where two people can implement the same impl and
differently, yes.
And intermix. One thing I would add is that really, I think also someone pointed this out before, but that this problem of impl foo inside of a function bar is not nearly as bad as a macro use that expands to an impl foo, because you can kind of see where the impls for foo are relatively easily in a relatively lightweight fashion, but having to expand all the macros out is much worse.
That kind of sounds like the point where your IDE either uses Rust Analyzer under the hood or it just doesn't work.
No, I mean, the problem is Rust Analyzer can't handle this.
Oh, okay.
I mean, it can handle it. It just has to go expand macros, which is very time consuming. So your dot,
I see.
Your dot is slow. But I think all of these things are cases of this one, especially macros are complicated and it's not a short fix. I think we should wait. We don't have any clear route here. Wait till we're done with Rust Analyzer, or we feel like it's really working well and it has been forced to make some compromises, and then we can review what those compromises are and think about it. Right. Which one next? So the delegation, I think I saw this cargo feature resolution. I feel like that's kind of out of our scope. Is there a language interaction here, especially?
It's not a language interaction so much as the cargo team wants to do this, and if there's going to be a notable 2021 edition, that would probably be a good time to tie it to. So we'd like to coordinate it. If there, for example, isn't going to be a 2021 edition, which at the time this was added, that was a question, then cargo would need to handle this itself somehow.
What does it mean for a feature resolver to be different when you can have the same feature in different edition crates?
So from what I've seen of the current implementation in cargo, it just has the root crate. The root crate basically chooses the feature resolution.
Exactly.
Okay.
There is an opt-in feature resolver, and edition 21 would be considered opting. Edition 2021 would be considered opting in.
So basically the new resolver selects fewer features than the old one. So in a sense, it's a backward compatible change.
There's probably no way. Yeah, okay. It would be really hard for us to like migrate this in any automatic way.
Yes.
Okay. I want to bring up something about, it's kind of only half us, but I saw some other mentions of things like this. I don't know, I guess it was a little different, but one thing I think we should think about is what I wrote here about into impulse. I would be curious to sync up with the lib scheme on this a little bit, but like there are a certain set of, for a while it was pretty standard, and I'm sure it's still true, that we just had what we called acceptable breakage from adding impulse, especially as with or into impulse. And they came from basically the Rust trait resolver kind of in doing extra inference. Being a little too smart, so people would write things like, I don't know, they would write, I'm trying to think of a very concrete example, but partially specified types with an asref call, and it would be unambiguous, so we would figure out how to resolve it. So it'd be like let x equals foo.asref or something, I don't know. That's not a great example, but, and when you add a new asref impulse, suddenly there would be two choices for what the target type might be, and you get breakage, right? And a fix is to kind of manually specify the type. My opinion that this decision to do aggressive inference here hasn't aged that well, but it's not a highly informed opinion. I mean, I don't know, but it feels like it's bad that we regularly people are breaking. And I thought we could consider that we might add annotations to traits like asref and into to limit that inference, at least in a new edition, right? Like maybe annotations are ignored in earlier editions. But,
there is a common pattern here where people are hesitant to make something more general because they will get inference breakage. And if there are ways we could help with that, that would be nice. This is one example, changing from I accept stir to I accept an asref, or similar kinds of things, switching to accepting an into or an similar. That kind of thing, it would be nice if we had the whole default type parameters thing, which never has happened.
The canonical implementation of this trait or whatever that inference would fall back to would be so nice so often, except that as far as I understand, it's evil.
One case I've run into, for example, is I want to accept a slice of strings because I need an array of them, and I would be willing to accept a stir or a path buff or a b-stir or any number of other things. And that works beautifully every single time, unless you want to specify an empty slice, which turns out to be the common case. In which case, what kind of an empty slice is it? I don't care.
Right.
Yeah.
That would be really lovely to fix. There is, I think, a proposal for default type parameter fallback. How feasible is that?
It's worth noting these are sort of different problems. They're related. Like, in one case, I want to do less inference, and in the other case, you want to do more. Right. But, yeah, I mean, the fallback, I guess, we've been around and around this. I think that the most general version, the main problem is conflicting fallbacks. So that's one main problem. And there are some variants where we make conflicting fallbacks kind of impossible, basically by limiting the kinds of places fallback can be added so that you can't add it in more than one place. So if you allow that you can have, for example, this reminds me, so we have defaults in structures. That's not what I wanted to say. What's the example? I don't know. I don't remember the details, but I remember that we had some variants where we would kind of limit the fallback to cases where its value was implied by struct defaults. I think that was it. So the usual example is like box A, you have an allocator type, standard alloc or something. And you want to make the function generic over the box. But you want this to fall back to standard alloc in the event that it's not specified, probably because it's being returned. There were some proposals where the idea was to guarantee that the only defaults were ones that were already coming from a struct definition, and therefore like they can't disagree because no matter how many of them you have, they'll all be the same as whatever's in the struct. And in fact, maybe you don't even have to write it for that reason. That doesn't really solve the example you were proposing.
Right, that handles box, but it doesn't handle as ref stir.
I guess I would say some study needed. I would be not terribly keen on just, I'm nervous about just sort of the most general forms of this because it really reveals details of how the type inferencer works that would make it harder to switch to new implementations. And some of those details are already revealed in ways more than I wish they were, but we'd be making them significantly more revealed. But maybe if we targeted I think having some examples of these are the exact kinds of cases we want to enable.
Right. The specific case of I want to generalize the contents of this slice while not breaking everybody who writes empty slice would be a really common case to want to address.
Yeah. All right, so we're about out of time.
Option as well, actually. What type is your none?
Right.
Yeah.
I think we're about to type the same thing. Claire, go ahead.
I'll let you type it.
I often wish the none was an option of never, and then it just did the right thing or something.
Okay, well, we're about out of time. I feel like we did a reasonable job of going over these things. We've not covered everything. We haven't really, the other side of this conversation that I want to think about is the like, what do we think is Rust's, what is the biggest problem that we're trying, what are the big themes that we're trying to address? And does that inform our prioritization of our efforts? Like, you know, does that make any of these things more important than any others? I think for sure some of the work we've been doing around addressing what we once called C parity and stuff kind of implies a certain theme that it's really important to interact with deeper system software in smoother ways. I don't know. I think that would be helpful for. I would find that useful if we could state our goal in some way like that. But I also wanted to kind of start bottom up and then go top down and try to make them. So maybe we'll keep talking about it.
Sounds good.
All right. Thanks, everybody.
Thanks.
Bye.